short notes today. The first one is sequence, which believe it or not, we'll talk about that. You got 1,000?
Yeah.
You subtracted 1,000 from 1,000 and still got 1,000?
Wait, the last one, this has 0 minus 1. Once I do it.
We will talk about it once we're done with this. Sequences was how 5th grade started out. And if you just remember what a sequence is, it's nothing more. The technical definition there is the ordered list of numbers. Really, we also call it a pattern. I'm not going to spend a lot of time on that. That was this 6, 12, 18, dot, blank. And you can tell that the pattern there is, or the rule of that is, you're just adding 6 every time. So this would be 24 and 30 and 36. But also with that, they throw at you the term, or the word term. I can't say term there. What is a term? Question mark, question mark. Well, it's pretty simple in that this would be the first term. It's kind of like the item, the number, whatever's in there. This is the second term, third term, and so on and so on and so on. So if I asked you for the sixth term in this sequence, you would tell me that it is the number 36. By the way, another way you could get every term there, if I asked you for the 10th term, you wouldn't have to list all those, because what do you do it actually do? This is 6 times 1, 6 times 2, 6 times 3, 6 times 4. So the 10th term would be 6 times 10, which is
6.
a tough one. 60. 10th term would be 60. That's pretty much going to get you there with the sequence there. Another blank piece of paper, because we have just one more thing. Fortunately, it starts with the same letter. It is called scales. And that, the ever popular scale thing we usually talk about, is a thermometer, even though you never see one of these anymore. And what really is a scale, but it is nothing more than a kind of a number line. So here's my thermometer. Here is 0 degrees. When we have a thermometer, we've got 2 different, and again, because we're just foolish and stubborn Americans, we have 2 different scales we use. Mostly we use our scale, which is the, is it like this, Fahrenheit? Make sure I spell that right, because I don't want to give you the wrong. Fahrenheit. Fahrenheit. God bless you. That's our customary one that we use. Nobody else in the world will use it, but we will. And the goofy thing about our scale is you have 0 degrees. 32 degrees is a special number, because that is where what happens? It's freezing. Water freezes at that temperature. And then we go all the way up to 212 degrees, which is where water boils. Like I said, the smart people that make up the other scale we use, which is called the Celsius, if I can spell it, Celsius, they said, hey, why not, if our benchmarks are freezing and boiling, why not make this 0 degrees on the Celsius side and make the boiling point 100 degrees? That would make so much sense. And that's what they did, just to make their life easy.
Yes.
Which means what? Between 0 and 100, there's like 100 tick marks, but between 32 degrees and 212 degrees, there's like 180. So if something goes up a degree Celsius, does it go up more or less than 1 degree Fahrenheit? More, because there's fewer of them between that. You know, if you go halfway here, if we go 50 degrees Celsius, about how many degrees would that be Fahrenheit? By the way, remember doing halfway? Did we do halfway before? What's halfway between 32 degrees and 212 degrees? Well, you know there's 180. What's half of 180? Anybody? 90. So if you add 90 to 132, you get 122 degrees. So 50 degrees Celsius would be 122. I hope that's right. It should be right. If my logic is right, that should be right. No, not always am I. What does it say? Our body temperature is what? 98.6, which is 37 degrees Celsius. How about that? That's about right. 98.6. Anybody go to the doctor and they say your temperature is 37 degrees? Nope. Okay, because we're just
Same way. If freezing in Celsius is 0 degrees, how is it like? Wouldn't that be warmer than like 32?
No, 0 degrees Celsius is exactly the same
Yeah.
as 32 degrees.
Oh, okay.
So when you go to Celsius and they say it's negative 10 degrees Celsius, that's really not that cold. I mean, it's probably, what, 20? Well, I guess it would be, I don't know how many degrees there. Negative 10 is probably 10 degrees or something. Wait, it must be. I wonder where negative 10 matches up. Is there one in the book? Does it show us that in the book? No, it doesn't go to negative 10. Anyway, when you look at scales, remember the important thing to do to look at scales is look at what each tick mark is using. For example, so let's say I've got this scale, whatever I'm measuring here, and this is 10, and this is 20, and this is 30, and you just have one little tick mark in between those. This is 40. Let's say you're measuring how much liquid or something is in there, and the liquid goes up to here. I should blow that up a little bit. How many, whatever that is, milliliters, milligrams, centigrams, milligrams, how much liquid would this be right at this point right here? You can't say it's 21 because that every increment is not just one thing. Why? Because between 10 and 20 there's only 2 marks. Remember, count the spaces. So each space is worth how much? Between here and here is 10. We cut that into 2 equal pieces. Each space is 5. So this little tick mark here is 15. This little tick mark over would be 25. And this one would be 35. So it's very important to look at what each tick mark is so that you know what your scale is. For example, if you look at your book on look at page 52, please. Page 52, please. Looking at the thermometer, which is there for letter D. Practice letter D. Looking at the Celsius temperatures on the right side. What temperature is the Celsius on the right side there? And again, you have to figure out what is each tick mark worth there. How many spaces are there between 20 and 30, and then you kind of divide that by whatever it is. It would be, Frankie? It is 22, because each mark is worth 2 degrees, because between 20 and 30, they cut it into 5 equal pieces. How about in Fahrenheit? How about in Fahrenheit? Victoria?
72 degrees?
It is 72 because notice how they're smaller, but they also cut them into 10 equal pieces. So 72 and 22 are exactly alike. How about that? I think you probably can handle what's going on here, so we won't bother you.